Welcome to Pointwise's Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a couple of minutes. In this video, we discuss troubleshooting techniques for issues with high-order export. Today's video will focus on changes you can make to the solver attributes to improve the export process. Here we are in the Set Solver Attributes panel, which can be reached by going to CAE Set Solver Attributes. Keep in mind that the high-order attributes will only become available if the CAE solver is set to a format that supports high-order export. The first parameter we will discuss is the convergence cost threshold, shown here with the default value of 0.8. We have found that higher values such as 0.9 or 0.95 actually perform better. While this may seem counterintuitive, a higher value will cause cells near troubled spots to become better shaped earlier on in the smoothing path, which improves the quality for the worst node. The second parameter you may want to change to improve performance is the number of weighted condition number smoothing passes, and here with the default value of 1000. This parameter determines the number of iterations in each of the 4 possible global smoothing passes. The first smoothing pass calculates the quality using just the weighted condition number, while subsequent passes add in the normalized Jacobian in more and more accurate levels, thus requiring more and more computation time. The algorithm will only proceed with the next smoothing pass if there are any negative Jacobians at the end of the previous pass. If you notice the Qmin is still negative or is still increasing towards the end of a smoothing pass, this may be an indication that the number of iterations is set too low. Finally, if you are watching the display window and see the Qmin value oscillating between a few specific locations, you may want to lower the step size relaxation factor, shown here with the default value of 0.05. This factor is used to limit the distance a single node can be moved each iteration. If the value is too high, each node is allowed to move within a larger radius, meaning it could potentially take longer to find an ideal positioning for all nodes in the mesh. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, drop us a line down below or connect with us on Twitter, which is linked in the description. Thank you all and have a pleasant Tuesday.